Welcome, everyone. My name is Tony Carcamo, president of Civil CAD Learning Solutions and also president of the DFW BIM Infrastructure User Group. So today we're going to do a quick little intro over Civil 3D Hydroflow Express tools. So if you've never used it, I'm going to show you how to take advantage of that. If you're doing culvert analysis, pipe analysis, maybe some weirs for detention pond, street gutter flow. So we'll kind of go briefly over all those tools, even a drainage analysis for like a drainage swell. So let's go over it real quick. Let me share my screen. And actually, let me share it now. And let me know if I go a little too fast. I'm going to go open to some storm drawing. Let's see if I can find one. Okay, so this is a simple subdivision. And typically when I'm designing, let me go to my view, split it. And I'm looking at my drainage. And I want to verify, especially in the very beginning of the stages, what size pipes are we going to use? I already did my preliminary drainage analysis for proposed conditions, post and existing conditions, and I want to size some pipes. Now you can do it in a spreadsheet. If you got a more advanced spreadsheet, I have my own personal one I've used for many years, and I keep tweaking it. So it calculates a lot of stuff for me, even to hydraulics and velocity flow. But there's also limitations in the spreadsheet because the spreadsheet can't calculate when the water is from partial flow into full flow conditions. So if you have a long pipe run, like from this connection here, and I have a pipe size change right here up to this horizontal bend, let's say this horizontal B or this Y where this lateral comes in, the spreadsheet won't know when that turns into a full flow condition pipe. So that means that here, as you can see, let me see if I can find a better example. Yep, let me use this one. So as you can see, maybe this is my hydraulic grade line, this yellow line here, and this is in partial flow, okay? But eventually you'll start having jumps, and then at this point, you're outside the pipe, okay? And you're in full flow conditions, so your formulas will now change. Now, if this was one pipe run, there wasn't a lateral here, there wasn't a Y connection that said it continued and went outside the pipe, now you're in full flow conditions. That spreadsheet can't do that and just automatically create, I've never seen one, automatically create another line item, in there. So that's one of the limitations I've seen for spreadsheets is it just can't do that. You have to go insert that line item and start filling in the blank, filling that data in again. A typical spreadsheet could look like, let me bring up the one I have, a simple one. I do have one that does calculates actual routing. And so I think I'll pick this one, the same project. This one was, what was it? Subdivision, Bailey Ranch, Stone Hydraulics. Okay. And you'll have something like this. Everybody's a little bit different. So what here is I'm calculating what my drainage is, the pipe, my Q total, Q total, and then what my friction slope is, the Q cap. Mine calculates the maximum capacity of that pipe, and then your hydraulic jumps and the type of inlets. I can come in here and figure out what the type of inlets is, and at the bottom, also type in what your rainfall intensities are. So you're getting some of that from the city. And then all this information now I can just paste into my sheets and stuff. So but a typical very simple one. Now I have another one that's much bigger that does a lot of routing and stuff. So but let's talk about some of the hydroflow tools. I want to do a simple pipe sizing for this pipe. Okay. And this pipe, let's see, it's probably this one right here. And if I go to the analysis tab, design, launch express, and I use this for every project. I'll just come in and do some simple analysis. So if I go to channel and go to circular right here, you know, I don't know why it's under channels, but here I can say, okay, I have a 2-foot pipe, and I typically just type in 100. I don't have to actually type in the elevation of the pipe. I'll type in 100, what that slope is at percent, okay, 1%, and what that coefficient in value is for concrete pipe. You can get that from the manufacturer, or you get that in one of your drainage design manuals. So I typically have 0.013 for concrete pipe. Some people do 0.012. If it's a HDPE pipe, it's like a 0.01 or 0.011. But like I said, you can get that from a lot of hydraulic manuals, or you get that from the manufacturer and what that coefficient value is. So that's friction of water, hitting the pipe. Then you can calculate, okay, what is my Q? So if you already know what the amount of water that's coming into the pipe from your drainage area map, I can type that value in here and say, okay, it's now 2.5. And hit run. And here we go. Now this is telling me, okay, the water flow is 0.45 inches. The Q is 2.5. The velocity, which is what you want to look at, is 4.71 feet per second. Okay. And so if this was outfalling into a grass area, you would probably want to put some riprap down, because typically most cities say they don't want the water coming out faster than 2 feet per second, because it will cause erosion. So here, if this was my outfall pipe and I had a head wall there, I would actually have some riprap to slow down the water, or dissipator blocks. 4.7 is not too bad, but if you start getting the 6, 7, 10, 12 range, you do want some rock riprap to slow that water down so it doesn't just erode the ground and create a pit. So very simple. Now, what is the max capacity of that pipe? I can go Q over the depth. And in here, I'm going to type in T for the intervals. And it's doing these intervals. And you can see what that maximum capacity is. Now, I'm not going to use 2. I typically do like let me see if I do 20. I might break it down even smaller to tenths. There we go. So I do 20 increments. I will typically do 1.9. I won't ever use this number. I'll typically use that 1.9 number. And then here, you're basically only at full flow conditions. Full flow means it's a maximum capacity, and the HDL is above the pipe or inside the actual pipe wall. So if your pipe is in full flow conditions, like here, you can see this hydraulic line. This hydraulic line means that this storm pipe here is under full flow conditions. It's a maximum capacity. It's running full at all times. So this is one little problem with it. This tool doesn't provide you full flow conditions if the pipe's under pressure flow. So you can't use this number here. If the pipe in the HDL is above the pipe, that number is for partial flow here. For full flow, it's a quick way to calculate this is Q over A. So your Q, which if it's 5 or 10 CFS over your pipe area, will give you the full flow velocity. So just remember that Q over A for full flow pipe. So usually I have a little spreadsheet, does it in my head. And this will tell me, and I actually have a label that does it automatically for me automatically. Let's see here, right here. So I created expressions. So now if I type in the size of the pipe, this is automatically calculating my velocity, my friction slope, and Q cap for me automatically in my pipe level. So this is something I custom made. That way I can look at it and say, okay, Q cap, I'm not over my Q cap. You don't want your Q100 over your Q cap in partial or full flow. But that's one simple way I do my pipe. Now, if I'm doing a swell, and you've got a swell in the back of the yard or a big drain swell, this is where I can come in and do a drain swell and say, okay, I got a 4-to-1, both sides. The depth, maybe the depth is going to be 4 foot. Okay. And I'm always just using 100. And then the slope of that swell maybe is 1%. The end value is what, 0.03, I think, for grass. But if it is concrete, 0.013. And then I'm just going to go increments of 20 to see, what that capacity is. So here it's for 4 foot deep, it can run 493 CFS, that swell. But here you want to look at that top width. That's 30 feet tall. At 4 foot, that's 32 foot across. That's the wet perimeter across here. Now, if I know what that Q is, I can just switch this over and say, it's 15.25 and run it. And there we go. It's telling me at 15.25 CFS of water runoff, it's only 1 foot deep, a velocity of 3.2, and the top width, which you want to pay attention, is 8.7, because you want to make sure that that swell and the water is being detained within a drainage easement. And you might have some restrictions about a fence or a property line, somebody's backyard. So you got to pay attention to this top width right here. Okay. Let's see what else. And you can also do different types of drainage swells. You've got irregular shape. I've done that before. This is for gutter flow. So it's important because when you're doing a road design or you're doing a subdivision road and you want to calculate how much gutter water flow is in the road. Where's my little pen? So most cities will tell you what this value is. So if this road is only 2 lanes, most cities will say, well, you can only have 1/2 of that lane. You can't flood water more than the whole lane. So usually the city will tell you that. If it's 2 lanes, usually it's 11 foot. If it's 2-lane or 4-lane road, but you'll get that from your drainage design manual from the city or the county, or whoever the reviewing party is. So I will usually come in here and calculate that in here. So I'll say, okay, if I'm doing gutter slope to figure out how much water is coming down the road, I can type in here. You can see SX is that. So that will be, let's say most crown roads are 2%, so 0.02. And then here, SW. So that's that urban gutter. You always see that little dip in here. I think I calculated it was just that. It's 2 foot and you're dropping 6 inches. And it could be, 15 or 20% based on that detail. Your construction detail of that urban gutter will tell you that. Some people don't have, they'll keep it simple. They don't want to make it technical. So that SW is still 2%. And so I don't have a dip. I'm just keeping it simple. The gutter width is 2 foot. Elevation, I'm gonna say 100. The slope of the road, that's the slope of the profile of the road. And then it's 1%. It's 0.013. And then your Q, how much coming down the road before you get to the gutter. Maybe it's 3.5, 3.4. Now I can calculate, is it above my top of curve? You don't want that. But I'm also looking at the actual width, the top width. Now top width says 10.6 feet of my road is being covered with water. Okay, so that's also important because this line will typically just keep going on. So don't let that fool you, because the crown road, if it's just 2 lanes, it's probably right there and then it goes back down. So right now I almost have 11 foot of a road lane covered with water. So typically some engineers will go and check that, but you can double check that with this software. Let's see what else. Then culverts, so if I'm doing a culvert, I can say, okay, the culvert downstream, like a typical like TxDOT or a transportation driveway, a culvert, you want to calculate that. I'll do that in here. I could say, okay, it's 100. The length is, 30 feet across this driveway. The slope is, 0.5%. And then it auto-calculated what the upstream would be. The rise is the pipe, 18-inch pipe. The shape is circular, but I can always do box or elliptical or arch, but I'm doing a circular pipe. The span is 15, so I actually wanted an 18-inch pipe, circular, okay? And you can do 2 barrels, 1 barrel in here, up to 4. I'm doing 1 barrel. Notice here, it was defaulted to 0.02 for your friction. I'm doing 0.03. And you got different types of covert types in here. You can pick and choose which covert type you want to use. You'll have to look at the manual and then help to show you the type, if it's flared, if it's vertical, the head wall entrance right here. Okay. Then what is that top? Well, let's say my top is 105 feet or something, the top. So that top would be the elevation right here. What is that elevation here? Okay. Right. And then the top width, maybe the drive out is only 25 foot. And then the crest is that side crest width. And so if my road is only 13, I mean, my crest is only 5 foot. So I have 25, 30, maybe less than that. Let's make this a little bit wider. Let's make that 40. Yeah, so it'll be 40. Because we have 25, 30, we'll keep that 30 foot. Okay. All right, that means I now have 30 foot here, and then I got 5 foot of side slopes of the road. So give me my 40 for the pipe. Okay. And then you can type in what's the minimum Q coming into it. I said 5 is coming in, the max maybe 15 in increments of 1. Your tailwater conditions. If you're doing crown, normal, now you need to get with your engineer, how you're doing your calculations for your culverts. So I'm using DCT over 2. So I'm going to run it. And here it's telling me, okay, if let's say I have 8 CFS, you can see that I'm doing fine. It's not going over the road. It's actually getting held up a little bit. So when the water doesn't freely flow through the pipe and it starts, filling up the side of here, it's an inlet controlled. Shows that inlet is controlling the water going out, coming in and out. So you can see the water, it starts rising up. That means it's inlet controlled, but we're still doing fine. Let's go look at the hydraulics. So 8, we have a velocity down. I'm looking always at velocity down, almost 5 CFS coming out, and also your HDLs here. So typically I'll come up here and hit print. And I want to select one. I'll click 8 and then hit print. Hit a report. And I'll do a PDF. And I will insert this into my plan sets. That way the reviewing party, document, yes. And I'll show you what it looks like. Here we go. So they'll get this. You can paste it into your plan sheets. That way the reviewing party can see the information. Okay, what is your velocity? What is it? Is it going over your driveway, which you don't want? So I have plenty of space for more water to come in. So a very helpful little thing you can do for your plan sets. So I do culvert analysis all the time on my project. I'll come in here and I'll put this in my plans. If I'm doing inlets, you can do inlet in here. So you can size inlets. And you got different types of inlets in here. Notice that some of these have grates, slotted, drop inlets, right here, drop curb. So you do have those flexibilities. You're just plugging in information. The most important information is, getting the slope right and what your Q is coming into it, and it'll tell you the information. Now, if you're doing hydrology, and now I won't get into this because that's getting deep into the hydraulic and hydrology, but you can do, if you're doing modified rational here, or if you're doing rational or SES method. So the SES method is basically for drainage areas above 100 acres, and you're trying to find your peak flow in here. So you have your three different methods. Now, typically you're going to get that from the city. The city is going to dictate and tell you which method you should be using. Most of them use the modified rational method. So Q equals CIA. That's your area times your intensity times your coefficient. So if I'm doing a subdivision, typically it's around like 0.5 to 0.7. That's going to get from your manual. It'll tell you what that coefficient is per your development type. And your intensity is also coming from your manual, or the state will provide you that. So TxDOT can give me one for the county, and that intensity could be like 8.55 or 10 or something. Your area is acreage. So you're multiplying the coefficient times your intensity times your area. And then you also have weirs. So if you're doing a detention pond, I do detention ponds all the time, and I don't know what that weir needs to be for the 100-year water to be released out of the pond. You can come in here and say, okay, the bottom is 5 foot, and then the top is only 2 foot. And then what is my Q that has to be released out of the pond? And maybe it's 35 CFS that has to be released. So here I'm fine. You can see but I also want to look at the velocity. The velocity is 4.2 of the weir coming out. So kind of fine. You may put some riprap. I would recommend putting the riprap at the end, because most of these, like I said, wants only 2 foot per second being released. But here, this may work. I can probably, it's getting close to the top. So maybe I'll do, not 5, but I might do like 2.5 for the raise up my weir here. So I use this to do a simple calculation for weir calculations of release, the release from a detention pond. You have other ones here. I've done this one too. I've never done this one. I've never even seen this one. I've seen this one, the V-notch release on a detention pond. I've seen this one too. That's one's very common. I've never seen this one. These two I've never seen, but I've done these 4 on pond release, detention pond release. What else? Let's see here. And you can save these out. Typically I'll put in here, storm SD 5 culvert, and hit save. And that way, when you create your report, the title will be up top, and it'll say SD5 culvert analysis or culvert. Questions, I think you can create your own IDF curve in here, or your own rainfall intensity. That participation. You can come in here and create your own. I don't think I've ever gone in here and modified it, but you can create your own in here. So that way you can use it over and over for if you're doing a lot of projects in your city and you're using the same IDF curve. So you can do that. Any questions on that? I mean, this is pretty nice. I come in and use it all the time from a pipe sizing, a simple pipe. Hey, I got some storm water going in here. How much water can this pipe hold? Just remember, this doesn't calculate full flow conditions. You just got to remember it doesn't calculate that. So I couldn't use it for this pipe here because that HCl right here is above the pipe. So in that situation, I'm just using my label that calculates that for me. I did a blog post on the community. Let me see if I can find it. Autodesk Community Voices. I actually did a blog post about this. Let me see if I can find it for you. If you want to create this actual label style that does your hydraulics. So I think I have one for even partial flow, but I don't share that one out. Let's see. Find it here. Here we go. Can anybody see my screen? Everybody can hear me? Sorry.
Yes, we can see your screen.
Okay, just checking share. It got kind of quiet. And I'm going fast because I have another meeting right after this. So sorry if I'm going too fast. But yeah, you can see this blog post. This is an old one I created in 2012, long time ago. Autodesk really liked it and put it in one of their books. And I'd show you how to create these expressions. And you don't have to use this. You can go and modify this. I had some users come in and say, hey, you can actually combine these two to create one. But here I'm doing step by step. Because some of these formulas are not in Civil 3D, so I had to break the formula. You can't just type in the Manny's equation into Civil 3D. So you got to take Manny's equation and break it apart to calculate friction flow, your K's in here, to calculate full flow velocities. So in here, I'm showing you how to create this. We've had some users say, hey, you can go and modify this. But this is just an idea. And how to create one. So But yeah, you can go and create this. That way you can just click on a Q in your pipe. So if I just type in a Q, turn on my little app. My little app will, when you click on a pipe, will show you what you're clicking in profile. So if I come in here and go to my Q, pipe property, and then Q, let's say I change this up to 15. Let me zoom into this one. So this label, I think it's this label, but yeah, it's this label. I can type in the Q and this information will update, but it won't update too much because this pipe is on partial flow. So you can see this information automatically updates and stuff automatically. So if I change my pipe size, let's see if I change my pipe size here. Came down here and say it's now a 30-inch pipe. You can see my information update automatically, and that just saves a lot of time automatically. So definitely, check out that blog post. If you like it, give me a thumbs up. If you don't, I'm sorry. So, but it's got a lot of views. I think it has 1,800 views. So I guess that's good. But questions about the analysis tool. It's not a separate tool. It comes with Civil 3D. You can use it all the time. And probably the two most I use is the covert tool to analyze my covert, and then the pipe tool. My swells, my two swells, it's usually this one with side slopes of 4:1, and then a V-notch swell for grading behind a residential property, and then also my weirs for a detention pond. Those are the ones I use most often, all the time. Next month, I'm going to be doing, should be getting confirmation here, Community Voices webinar with Autodesk to talk about the gravity analyzed network. So we'll get deep into hydraulics in there. I'll explain some of how to use this app to do hydraulics. And that should be a fun little exercise if you've never used the tool. I've used it a couple times. I still use my spreadsheets. Sometimes I'll double check myself and go to SSA. And so I'll push it SSA, let it run its analysis. I can see what's happening, see if any stormwater pipes are surcharging. But yeah. Now there are other ones in here. You got the storm sewers, which is kind of similar to SSA storms, hydrograph, stage storage. So I use that for calculating volume in a detention pond based off my surface. So that's something I use often, all the time. For your detention pond, you should be using this for your detention pond to create your detention pond. Now, I think it's Storm Stores has a detention pond little app in here too. Let me see if it does. Could be wrong. It's the other one. It's the graphs ponds, and you're inputting the values, the areas to calculate your pond in here. So I can put pond. So in here, yeah, you can go and create your detention pond analysis by trapezoid contours manually or chambers, and you can also do calculate SCF method, rational method, stuff like that. So I don't really use this tool that much, hardly ever. It's mostly the Launch Express and stuff so that I use to do calculations. So some companies don't, if you're a young drafter, EIT, they don't go into this until you get a little more experience. But it's good to learn, show your engineers or your hydraulic engineers that you are capable to do simple analysis. You're just basically inputting data in here. So like I said, what's the pipe size? 18-inch. Well, that's what, sorry, it won't let me do anything right now. I think it locked up. So there we go. So 100, the pipe size is 15 inches. That's what, 1.5 feet. No, 1.25. if it's 15 inches, the slope of the pipe. Now pay attention to these percent. Some people will type in 0.01. No, that's, foot over foot, so this is percent, and then grass. Now, if you go to the help here, well, not the content, and in here, you can get some really great information. So I could come in here and go to reference tables and your runoff coefficients. So in here, you can type in what that coefficient needs to be. Manning's the end value. Remember, I was typing 0.013, and that's for it says concrete pipe. Yep, so concrete pipe. So I'm typing that end value in here. If you're doing grass, I did 0.03. They're using let's see here, earth right here. So if I'm doing grass, it's 0.03. That's where I'm getting this table to type in that end value here. So if I'm doing a pipe, 0.03, 0.02, 0.012 also works too. So I've seen that often too. Remember, that's friction that affects water flow. Okay, good. How many have ever used any of these tools? Anybody? I've used it for probably 10 years now. I was lucky enough, that I worked under a senior engineer that was, in charge of me 30 years plus, and he actually sat down and made me learn hydraulics and stuff. So, and I had to do it by hand. I had to do all the calculations by hand for the whole storage system, then learn it, put in spreadsheet. Then a couple years later, I started using the Hydroflow Express tools and stuff. So they're pretty simple. If you have any questions, you can always come in here to the help, menu, and they'll help you guide you through here. Their menu is pretty good. Yeah. But this tool here is not for a whole system, storm system. It's for individual parts and stuff like that. If you're doing a whole system, that's a spreadsheet, that's SSA, that's the analysis gravity network, and that's also storm sewers. So if you're trying to do a whole storm system, you're going to use those other applications. If you're doing Bentley, that's StormCAD. If you're doing hydrology, you're doing in the hydrographs. You're also doing SSA for drainage areas. You also can use PondPack to do drainage analysis. So there's many software out there. Now you got Innovice that Autodesk bought, and they got several different applications based on what you're doing. If you're doing hydraulics for pipes, or you're doing hydrology for drainage areas and watersheds. So that's something I'm start teaching myself, is that product now, and compare it to SSA. So I use SSA. So in here, yeah, you could take this storm system and say export to SSA. I can come in here now and pick the storm system I want to run an analysis on. Maybe I just want to run it too. I'll go ahead and pick all three of these. And then what I'll do is I'll throw it into SSA. As long as you got some Q information in the pipe for every pipe segment, it will run that analysis for you. Now, SSA, I like a little bit better because you can create those rainfall intensities a little bit easier. And it does animation to show your profile, and you can see the water animate going through your storm pipe. So it's pretty cool. And you can actually it actually has its own spreadsheet. So you can actually save a spreadsheet when you're done in SSA, and use that to paste it into your plans. So questions? So yeah, I don't know if y'all remember back several versions back, it used to be a separate application. When you hit open, it was an actual different icon on your desktop. Now there's kind of imported into the ribbon in here, but it used to be a complete different desktop app, so now you don't even see the desktop app. It's just inside Civil 3D and you run it through. So, was I accident? Any questions? I know we kind of went through it a little bit fast. I did record this, that way you can come back and watch it. But if you're not learning, hydraulics, ask your engineer to teach you some of the basic stuff on hydraulics. I actually have 5 hydraulic manuals in my shelf over here that I've been, I read and learn from. So it's not rocket science, so, but this is something that most engineers are very picky on, who's doing hydraulics. So I've been doing it for a long time. So most companies I worked for when I was a CAD manager, I was doing the design, I was doing the hydraulics, I was doing the tension pond, I was sizing the storm pipes. So and then engineer would just double check. So in here, and I usually create these tables in here to double check my work, pipe coverages and cues and stuff like that. So laterals over here, double checking lateral hydraulics. But yeah. Has anybody ever used these tools? Any of y'all, the Launch Express tools for pipe sizing and stuff?
We've used the Hydroflow for really a lot for inlet analysis and swale analysis.
In here and in the swell. Okay.
Yeah. Yeah. We do like the inlet analysis a lot. It does seem to be, it's much easier than any other program we've used. And it seems to give good, accurate results.
Yeah. I typically have it in my head. I've learned over the years, just rule of thumb. If the inlet's on sag on a sag on a road, it's usually, when I'm doing quick analysis, it's 1.5 times the length. That's the maximum capacity of that inlet. And some people will say 1.25. I'm usually conservative and go 1.5 and say, hey, this inlet. So if it's 10-foot inlet, it's for 10-foot inlet times 1.5, the max capacity is 15 of Q that can go in there. Now, if it's on grade, I usually say 1. So if it's 8-foot inlet, the maximum capacity is 8. And that's my rule of thumb that I use when I'm just running in my head. I'm designing the pipe, and that inlet is on a grade, means that it's not on a sag, it's on the road that's sloping down. And it also varies based on the slope of the road. Usually these roads, or most roads I'm looking at, is 1% or flatter. That number might go down even more if the slope is greater, So if I'm looking at something that's 1% or less on the road, I'm thinking in my head 1 foot, 1 CFS per linear foot of the curb inlet. So I don't know if that would help y'all. So when you're doing hydraulics, but that's just kind of my rule of thumb when I'm doing hydraulics and stuff. So until I put it into a spreadsheet and stuff like that, and then I'll verify that per like this analysis tool. So back in the day, several years ago, I used to use Flowmaster and CulverMaster too. I don't know if you have heard those two products. They're pretty old, been around for a while, but those are good ones too, Flowmaster and CulverMaster. So I did that for, I think, 6 years. And they're all
we used to use. We used to use Flowmaster too, but it was ancient, and
it is ancient.
So that's when we started using this as an alternative, and the engineers really liked it. So.
I'm hoping maybe later in the year we're going to create our own hydraulic and pipe sizing tool, my company, an app. So we're kind of excited about it. So we're hoping that we can get it done before the end of the year. A very simple one, probably more simple and dumbed down than this analysis tool. Okay, I'm all about making things very, very dumbed down and simple, and that's what I'm going to be looking at, is trying to create something very simple that maybe you can incorporate spreadsheets with also. So. Yeah, there are a lot of stuff out there that you can throw it into a spreadsheet and bring it back into Civil 3D and stuff like that. So, but yeah.
Yeah, the one thing we found about the analyzed gravity network is it doesn't really give us the reports that we need.
Yeah.
So so if you can kind of interact with a spreadsheet, that would be really helpful.
Yeah, that's kind of what we're thinking about doing. So, and have a more interactive spreadsheet with Civil 3D. So, I got some good ideas for it from simple analysis. Some people get really in depth with their analysis. So, but StormCAD, Pond Pack, okay, Christian. And there's other, from iSwim, there's other free applications you can use. I was using, I think, Hydro 8 for head wall outfalls. If you have a storm head wall, you can input values like your dissipator blocks. So if you have dissipator blocks in your head wall for outfall, I think that software, you can input the size and then how many numbers you have to figure out what your velocity flow out is in that head wall. So, and it's a free app. That was from, let's see if I can find it. So I used that in the past. Is it H8? I think it was H8. So if you go to the Federal Highway Administration website, they have several different, free software in here too. Bridge analysis, I'll draw it where that. Now it's H14. So it was H when I was using it. So there's HEC 14, HCS. What else do they have here? There's several different ones in here. Let's see here, culvert sections. Which one, where it was. And I don't think it was this one. There's another website where you can use free software. It was H8 or H something like that. So, but anyway, there's stuff in here too you can use from their website. So, but yeah, I gotta pause now to jump on another webinar or meetings, client meeting and stuff. But hopefully this helps encourage you to use the Hydroflow Express tools. Maybe you can show your engineer that you are capable of doing some of these cool, some of these analysis in here. The culvert tool is something I use a lot because I'll calculate it, for commercial or even subdivisions, or where I've got a culvert that's crossing within a transportation dot right away. So they want to see all the information. So I'll push that report and paste it into my plans. So, yeah.
Thank you so much.
But yeah, hopefully, you'll start playing around with it and using it. So, like I said, it just takes a little practice using it. And once you get familiar with it, I think you're going to like it. So now I don't know if Innovyze has their own version. If maybe Autodesk will eventually maybe remove this Hydroflow Express. I don't know. Because if you think about it, we got 3 hydraulic software now from Autodesk. You got all the Express tools, which is the first ones that came out. Now you have SSA, which is more advanced, and now you got Innovyze. So they have technically three hydraulic software, and then you got this tiny little one, which is Analyze Gravity Network. And then you got one in Hydroflow in InfraWorks, a very simple hydraulic tool in InfraWorks too. So they got quite a few. I wonder if they're going to eliminate one of these, But, okay, I will stop here. Anybody have any additional questions? I know we kind of flew through a lot of it. I just wanted to cover some of the key components of Hydroflow Express tools. Like I said, watch for my invitation from Autodesk to talk about the Analyze Gravity Network tool. So,
and when is that
like I said, all of them have positives and negatives, and there's no such thing as a perfect hydraulic tool.
Mm-hmm. When is that presentation? Sorry,
I submitted it. I'm still waiting to hear back when it's going to be. I don't think it's not going to be this month. It's going to be in May.
Okay, so, awesome.
So, yeah, I'll post it on the user group platform when it's available. And once this is once I stop, I'll upload this video to our platform. That's the on the YouTube channel. So if y'all go to the civilcatls.com, this recording will be up here. Our reward show, our meetup, quarterly meetup to this morning, will go up there. I'm going to be uploading Kristen's video later this week, but you can just go to the playlist and go under DFW and see all the most of the recorded content we've done so far. So yeah, 3 months and months. Yep. So in here. Okay, guys, I appreciate y'all coming on. I hope you enjoyed learning a few things and with Hydroflow Express. I highly encourage you to not be complacent and learn new products and new tools, even no matter what your age is. So, have a good week, and I'll see you back on the platform.
Thank you. That was great. Have a great night.
You too.
Bye.
Bye.
See you later.